So today we are going to learn the AC through resistor and inductor, which we name it as RL series circuit. So for a series, RL series circuit means the circuit is connected to a resistor with resistance R and also an inductor with inductance L. Okay. Before you start to learn this RL circuit, you have to be very careful that you have already learned your R circuit and also L circuit. So please revise it before you continue this subtopic. And you have to be very clear that for your phasor current and your phasor voltage through the resistor and inductor, which is in phase or there is a phase difference between them. So now we look at this series circuit. So we know that this is a source voltage. So I denote V as a source voltage. Okay, and then the V passed through resistor R is denoted as VR, which is your voltage across resistor, while VL is your voltage across inductor. Of course, this is a circuit, a series circuit, so the I that passes through R and L are the same. So which means that the IR and IL are actually same as the series or the source current. Okay, now if you revise back or you remember that what you have learned in your pure resistor circuit. So for a pure resistor, your V and I phasor are in phase, while for a pure inductor, your V will be leading I 90 degree or pi over 2 radian. In other words, VR and I in the circuits are in phase, while your VL will be leading your I. So we will get a phasor diagram. Then you will have a phasor diagram for your RL circuit as. So based on this, what you have learned in your resistor. So for your RL circuit, so your circuit will have this type of phasor diagram, which this is your VR and I for your circuit, and VR is a voltage across your resistor. Both of them are in phase. And then while your VL will be leading your I, means VL is leading an I, so it will be in this phase. Okay, and they are rotate in anti-clockwise direction. So in other words, for this one, we have VL leading I for circuit by 90 degree or pi over 2 radian, while for your VR and I in the circuit will be in phase. So when you combine these three in same axis, so you will get the diagram as shown in your textbook, page 309, which is this diagram. You see? Your VR and phasor I, your phasor I and also VR are in sine wavefront, and then your I will be in sine wavefront. Okay, while your VL is in cos wavefront, and both of them, this V0 R and V0 L will be different. So your V0 R and V naught L will be different. Means that both have a different maximum voltage across it. Okay. So you have this one, this diagram. So VR and I are in phase, they are in sine wavefront. So you have sine wavefront for both VR and I. And then you have VL leading your I and also VL leading your VR. So which is your cos wavefront. So this is your cos wavefront. So remember that for a RL circuit, your VL is always leading your VR and also I in your circuits. So as a conclusion here, your VR is leading, sorry, not your VR, is your VL is leading your VR and I by 90 degree or pi over 2 radians. So this is your conclusion for the phasor diagram. Okay, now you know that a phasor is actually a vector. So if you look at this vector, so for your VR is in this direction and your VL is in this direction. So voltage for a vector, so in other words, the source voltage V is actually the addition voltage of both R and L. Means your source voltage vector V is equal to vector voltage R plus your vector voltage L. In other words, your V is in this direction. In your phasor diagram, your V is in this direction. Okay, it's in this direction. This is your source voltage. So if this is your vector form, so whenever you want to find this value, so if you want to find this value, V, so remember it's actually a Pythagoras theorem. So you have magnitude of V of source voltage V will be equal to square root of VR square plus VL square. So this is the source voltage of your circuit. Okay, now for your VR, you can denote it as IR, and for your VL, you can denote it as IXL, which your XL is your reactance across your inductor. So in other words, this equation, when you have this both equation and also this equation, so you will get your I across your resistor and inductor, which is equal to square root of I square R square plus I square XL square. Because both are being squared, so you will have I square R square plus I square XL square. So in other words, factor out this one, so you will get I square R square plus XL square, this, and then square root your I. Okay, square root your I, sorry, this is not, this is here. Okay, square root your I square, so you will get your I R square plus XL square. So in other words, your I will be equal to V per square root of R square plus XL square. Is it okay? Okay, now here, if you look at this equation, I at here and V at here can be denoted as maximum I or maximum V. Okay, I and V at here, you can denote it as a maximum I or maximum V. Also, you can denote it as r.m.s or v.r.m.s. Means that if you're using this as r.m.s value, then this will be r.m.s value. If you are using maximum V for here, then you have to use maximum I at here. Both are the source, okay, source voltage and also source r.m.s. Clear? If you cannot be very clear, so V at here, you can be as source maximum V or source v.r.m.s. Well, I here is your I naught or I.r.m.s. Okay, you can both using this value of this one. Of course, there must be a pairing. So if you are using source maximum V, then you have to use V naught. If you are using source v.r.m.s, then you have to be using I.r.m.s. Okay, if you look at this one, this one. So in other words, this square root of r square plus xl square is equal to V per I. This value is actually, we denote it as impedance. Which is your Z value, and it has the same unit as your reactance and also resistance, which is ohms. So Z is equal to square root of r square plus a xl square. Okay, you can be understand as a total reactance and resistance in a AC circuit. Yeah, or in your definition, it means that it's a vector sum of the reactance and resistance of an AC circuit. So Z is actually the vector sum of your reactance and also resistance of an AC circuit, and it can be denoted as V per I. Okay, here you can be denote it as V naught of your circuit, and also I naught is equal to V r.m.s I r.m.s. Of course, this V naught is actually V naught of source. Don't confuse. Yeah, and this I naught will be equal to the I here. So you have to be very careful. V here is actually source voltage. So your V naught is the source voltage of your maximum source voltage. Okay, and you look at here, this. So from here, you actually know that your source voltage is leading your I and VR by an angle theta, which is here is your angle, by your angle theta. So how do you calculate this theta? So your theta can be denoted at here, which is using tangent theta equal to VL per VR. So tangent theta is equal to VL over VR. In other words, VL is I XL per I R. So it will be equal to XL per R. So your tan angle is equal to R. Okay, so this is your conclusion at here. When you have V of your source voltage is leading your I and also VR by angle theta. How do you calculate this angle theta? So tangent theta is equal to VL per VR. Why VL per VR? So if you look at this one, this diagram will be converted into this diagram. So your theta is actually tangent theta equal to VL per VR. So VL can be denoted as IXL and VR is IR. So I is same throughout the series circuit, so it can be cancelled out and equal to XL per R. So in other words, your theta will be equal to inverse tangent XL per R. Okay, now look at this one. So you know that there is a mean power for both pure inductor and also pure resistor. So for your mean power through the resistor, which you run in front, which is your mean power through your resistor, is equal to V0 I0 per 2 or r.m.s times your r.m.s, or is equal to I square r.m.s square R. Okay, this one is your mean power through your resistor. While for your mean power through inductor, still remember, the mean power through the inductor is actually 0 because it stores the energy, the energy absorbed by the inductor is equal to the energy released by the inductor to the circuit. So the mean power will be equal to 0 for your inductor. So now we have finished this RL series circuit. So know that what you have to do is please complete your exercise 18.6. Okay, please complete your exercise 18.6. So that's it for this lesson. Thank you and see you in the next lesson.